With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, we are given with a question, and the question says a particle of mass 1 kg and charge 1 by 3 microcoulomb is projected toward a non-conducting fixed spherical shell of radius r equal to 1 meter. Right? So this is the particle of mass 1 kg and charge this 1 by 3 microcoulomb, and it is being projected towards this non-conducting spherical shell having the same charge uniformly distributed on its surface. So it also has 1 by 3 microcoulomb. So find the minimum initial velocity of projection requires if the particle just grazes the shell, right? It just passes the shell. So what is the minimum initial velocity? So applying conservation principle of angular momentum, we can write that mv naught d, the distance it will be traveling, right? So that would be equal to mvr, right? So the angular momentum of this spherical shell, that is mvr, and the velocity, the angular momentum of this would be conserved, right? Conservation of angular momentum, we can write this, right? So from here what we get is velocity to be equal to mm gets cancelled, v naught d by r, right? This is the velocity. Since d is equal to, what is d? Since r is 1 millimeter, right? So shell of so the distance is given as 0.5 millimeter, right? So the distance, this d would be 0.5 millimeter. So we can write this to be equal to v naught by 2. Why 2? Because d by r is equal to 0.5 by 1. So that is equal to half. Since, right? So we can write this. Therefore, v equals to v naught by 2. So now what we can do is, the next thing we will be applying mechanical energy conservation principle, right? So we will apply energy conservation of total energy, right? So from there what we can write is initial potential energy plus kinetic energy is equal to final potential plus kinetic, right? So initial potential energy was 0 because it was already traveling. So it had some kinetic energy, that is half mv naught square, right? So that was equal to uf. So initial charge, that is q square by 4 pi epsilon naught r. This is the potential energy finally, plus tf, that is half mv square. The final velocity is half mv square. V in terms of v naught is given, right? We have found out the value of v in terms of v naught. So what we can write from here is that q square by 4 pi epsilon naught r would be equal to this half mv naught square minus half mv square, right? So half m would get common, v naught square would get common. So this is 1 minus, what was this in terms of v naught? So v naught by 2, right? So that is 1 by 4. So that turns out to be equal to, which implies that q square by 4 pi epsilon naught r is equal to 3 by 4. From here we get 3 by 4, so 3 by 8 m v naught square, right? This is what we get from here. Now what we can write is from here that since the charge is given, that is 1 by 3 microcoulomb, right? So which implies that this is 1 by 3. So that means 1 by 9, right? Into 4 into pi epsilon, right? We will substitute the value of epsilon now. That is 8.85 into 10 to the power minus 12. R is given as 1 millimeter. So we can write it as 10 to power minus 3. So that is equal to 3 by 8 into mass is 1 kg into V naught square. Right. So from here, what we get with the value of V naught to be equal to 8 by 3. So which implies that V naught is 2 root 2 by 3 meter per second. This is the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.